click yet. So we have been seeing a lot of different work packages, but I think a lot of the different technologies, different experts are giving us different work packages for different programs. So we have been seeing how to adapt speech modality to language models. We have been seeing ideas for aligning human values to our LLMs. So we have seen that there is a thin line between the definition of high risk and low risk scenarios. It's not pretty clear, it's not well defined. Well, as Eva was mentioning before, and maybe the situation in a home is low risk. You are asking just trivial questions about, who was the best player ever in football. But maybe there is some question that raises some violence, domestic violence problems, then there is some high-risk situation, right? In the best context. We have been seeing, in fact, how we introducing context learning into our LLMs. So the LLM, in order to be able to give us practical information, we need to use this context, right? And then we are seeing techniques how to infuse this context into our LLMs. We have seen techniques, for example, for multilinguality, reducing bias in our models in terms of the word rate. We want our technology to perform in all the languages the same. We want accessibility for all the languages, right? So we want to reduce in that sense in bias. We want also, as Elga was mentioning, align with the European values, whatever they mean. You can go to the European values and get the definition. We can control these biases. We can use and leverage unlabeled data because we need a lot of labeled data and labeled data. And we need a lot of data to adapt to personalization for our LLMs, right? And then it raises a lot of concerns about privacy, about security. I don't want my vacuum machine, my vacuum cleaner, just tapping on my conversation, right? I don't want Facebook using my data for improving my models. But I want personalized models, right? So we can achieve that thing. Then we need techniques for ensure that our data is not leaked. Then we have data, we can use this data for personalizing our models, but we don't want to give the data to the model admins, right? And this is the fight about. So how can we train our LLMs or whatever model we have, or speech models, in an efficient manner while keeping our data private? Right? This is the question we want to solve in some of the work packages. This is the showcasing we're proposing in this pilot. So what we propose? We propose federation. This is a technique, fancy technique that is called federation training. That takes into account all these kinds of things. Takes the security of the data. We don't want to share the data with other personalized virtual assistant at my home. I don't want that Facebook know if I am asking about buying other thing in whatever manner, right? So, but I want personalized questions. I want that to be that's to my way of talking to the way I using and course I'm using, right? I have my preferences, but I don't want to give this information to the on the models. That's it. So the use case we're proposing is that in here. So for example, we have an environment, a domestic environment. We have several computers, probably a laptop, probably you have a TV box. You talk to the TV now, you talk to the PlayStation, you talk to your phone, right? You have lots of interactions with these devices. And in each interaction, maybe it's not only you, there is also your son, your daughter, your wife, okay, your husband, your uncle, the friend you never want that comes to home, and then they talk to these devices, right? And then what you want to do is some kind of training, personalization of these devices, right? So the idea here is, can we use this data, but not only this data inside my house, but also the other's data house without any leak of information. At the same time, we improve and personalize our models. This is what federation allows us. So we can have a model that is in your house, but we don't want to share the model. We don't want to share the data. What we share is the model, right? So we have a technique, for example, that is able to share the parameters of a model that is trained at home. And then these parameters are somehow averaged in a cloud server that contains the big model. So you are not sharing the data. What you're sharing are parts of the model, right? And this is a way
to keep your data private. Okay, it implies that you need to train the system at home, but this is a computation problem anyway. That's the thing I'm trying to do here is we have techniques for keeping your data private. At the same time, we have big models, speech models, for example, for recognition, or LLMs that are able to perform the tasks was left. So this is the idea, right? We share these parameters. So the other thing, we don't only want to federate, we share the parameters between the houses. We also want to have another hierarchy. We want to have another hierarchy of federations. We want to share among the different houses without leaking my data to the house, of course. I don't want to know what my neighbor wants. I know that my neighbor wants to know what I do, right? But I want to use the data to improve my model as well. And this is what we're proposing at the end, right? We want to use your data without sharing your data with me, and vice versa. Then we propose another hierarchy that is among pilots, right? Can I use the data from Novi Sad using the pilot, that recommendation from a medical call center to improve the data in the house? Can I use the data from a call center in non-media to improve the data in Novi Sad? So on and so forth. So there is another hierarchy. Just a moment, sorry. So this is the main idea, right? How we can keep private this data. We have mechanisms, yes. What we're proposing here in the pilot one is to showcase an API, a cloud service, where you can send your model parameters, part of them, okay? And then we average somehow, and then a new model that takes into account all the interactions from all the different clients will improve the global model, right? So the 4 different pilots that will explain more in detail after. Again, we have this thin line, about what is a smart social scenario or what is a critical scenario, right? It depends on the situation. But the main idea is that get your data private, at the same time you personalize your models, you improve your models. For example, imagine that you can do this personalization by training in a federated way different languages. So for example, you are training Serbian, and by training data from Serbian that keeps private in this framework, can you also improve, for example, data processing, for example, recognition in Spanish? Can you also improve by training in Spanish plus Serbian, plus Maltese, plus Slovenian? Can you improve another languages? We will see. But we also do experiments. And this is our final goal. So, Nicola, you can put the dust into the first 3 rows, right? From previous table yesterday. Okay, this is the main idea, right? We have a global server, right? This is a big computation server that is able to, we're able to train a model there. We train some few parameters that are called adapters, and then this adapter is trained in a standalone fashion in each client. Then all of these parameters that we name adapter are combined in the server, and it goes iteration by iteration, so on and so forth. But okay, we are iterating this procedure every time we have an interaction with the model. Then this data is used for training, for improving your model, and then the average model is done in the server side, in the cloud. But there is no data transmission here, right? It's only model transmission. We also use techniques for privacy. So, for example, we can introduce noise, even not in the data, but even in the parameters of this model, just to avoid, for example, some malicious users. So, for example, my neighbor is a hacker, right? And they have access to the global model, right? So maybe you can obfuscate somehow this parameter, even using noise. There's a little bit of noise, and then you don't have this parameter. And still, you have some performance. Of course, you always have a trade-off, right, between good performance and the amount of noise you put in. This is called noise before aggregation technique. So this is the kind of thing we're going to show. I'm going to go fast because we're doing some experiments. Engineers, researchers like to do experiments just to be sure that things work before integrating. So just to give you the main idea is that we're using efficient techniques. We're using as a preliminary experiment some public databases that like this. some what we call instruction fine-tuning. They are just questions with some probably inputs and outputs that are used for training our model to be sure that for example, they align with the answer, right? And then we can test if the model performs well in this database or not. We're training with this data set that is called alpaca, and then we're testing our approach using lots of different models, multilingual models, okay, and seeing data. That is this kind of tests that are guessing the reasoning of the model in terms of math reasoning, questions of general purpose, mathematical history, this kind of question, right? So main idea here is that the models doesn't underperform after doing these iterations, right? Federation. So we can make these trainings. This is what we have already learned, in a server, in a cloud, sharing these parameters, and we are not losing too much performance. What we are going to do, and this is the last thing. Okay. Yeah, here. So I'm gonna pass the experiments, but how we're gonna really evaluate this thing in a real scenario. So, for example, the idea is not use these only public data sets, but for example, using this dialogue-oriented task data sets for using them for training our system, right? So we're talking about constructed dialogues, I guess, right? And how complex they are, or if they follow a pattern, they follow a script, maybe they'll follow a classical script like in a call center, right? Okay, I'm going to call for complaining. So this is like number, okay, which is the contact number, okay, this is scripting, right, in call centers. But in a regular conversation, you don't have this kind of clear scripting, but you still have a goal. Maybe you want to know something about your friend, maybe you want to know something about your mom, right? And you follow some social scripting, let's say. It's not clear enough, but there is. Can we leverage the data sets from Workpack 3, for example, dialogue-oriented tasks for training our system at the same time we perform tasks in a home environment? Okay, which means home environment. This is a home environment. Okay, this is our UX lab, user experience lab in Madrid. We have started recording some sessions. Of course, there are colleagues in my job. We are performing some kind they are like actors, okay? And then we are having, for example, a living room scene, right? So we have some characters, mommy, daddy, we have Tommy, right? We have Alex, and they're talking about trivial things. So which kind of things? We are recording, we already are transcribing it, right? Using a public available models. We already have the information about the terms, right? Because we need this information to transport the spoken language, the conversational language, the dialogues into structured terms, right? In order to give the context to our LLMs. So I'm going to test on this data, this real data in our lab, different technology fellows. So this is our idea. Which kind of things we're going to guess from them? So we also have some virtual assistants. You maybe have noticed, for example, from Alexa, from Google, that they are doing really, really short interactions. You don't have like a real conversations. So they don't have really context about your life. But that's at the end is not bad if you don't have a good, secure environment, right? Okay, this is how it looks, our evaluation data, right? So we have some terms, we have Daddy that is talking to Alex. They are talking about how was the training in the football day. He was talking about, I don't know, who was the name of the new professor, this kind of things you have to your daughter and your son, right? So we already have some questions in that dialogues. They are not structured, of course, but you're asking information to your friend or you're asking information to your wife, right? And then you can, for example, identify the roles. Implicitly, there in the conversation are the roles. Maybe sometimes they call by their name, proper name. Maybe you identify there is a mama, there is a dad. Which is the place when they went for vacation? Or which are the preference for one of the child? or which is the favorite vacation place for one of them. So this is the context. And these are the slots that we're talking about, for example, in Package 3, right? So can we extract this information for giving the context to LLM? And then at some point, we can ask our assistant to say us, where is the Valle de Huesca? Where is this Pico de Europa? Nice mountain in Asturias. What is it? Right? So this is the context. We need to have factfulness in our LLMs, right? And this is let's say, low risk scenario. These are the slot values, right? I'm asking about what was the day, right? I need to have some intent, the goal of the conversation, that is information about school. And then just to finish, for example, I'm asking here about the name of a new professor my kid had at school. And this is the values I want to guess from this conversation. Are our technology able to guess this kind of things, for example, in a private manner? So I guess more or less the idea is clear from Title 1. And I don't know if you have questions. You have the questionnaires. Maybe you can also. Of the questionnaires, there are some questions maybe.
Of course, you can use these papers to scan the question, or you can send QR code as the.
So, for example, do you think this idea about keeping private our data is a good idea? Do you see any flaws in the schema we're presenting, any weakness? Do you have a better approach, or what do you think about it? So, do you think your data is important? It is. It is. This is why you have a lot of applications that are for free. Sorry.
No.
Control the data.
Yes.
It should be the data.
They don't.
And the data is the one that creates the data. So data, like we're talking is yours. Very interactive. You're interacting with LLM, you're asking questions. This data should be used. Not from the owner of the technology. This is the point here. So any interaction you do with that technology, like implies your data, implies your behavior. Any interaction implies that it should be not used.
There is local on that machine which is provided by.
That's the point. The machines should be in your phone. It could be your router. Now, of course, maybe it will be your phone. They are starting getting more and more powerful. And then it will allow in the future to train models that now you cannot imagine you can train. So in the past, for example, I have in my pocket, but I have there on the table a force that is as much as powerful, and even my computer is exactly for it. And it's the line, right? Of the design. So probably after the year, we will have to train it. Like model, you phone. And it's what we are envisioning, right? So, and it's a very important question.
I don't know if I went out. You're fine. So the first time I had the phone.
It's really important to get this group because it will help us shape vertically.
Maybe 8 years ago, 9 years ago, when people started to send information like going phone number, there's exactly 10 and others.
Yeah.
And then I found and I turned off this function, but I still know that they are not collecting my data.
That's also that's the problem, right? You never sure about that. But I mean, big companies have been trying for this kind of bad practice. So not places, right?
But after 8 years, with my knowledge, everything, everywhere, each application are using, they are collecting the data.
We should have a legislation about that. How do you add? Right?
And now I'm not casting waves. whatever you want.
Right, I just don't know again to personalize advertisements, for example, so based on my last year's work. So, I like the kind of things.
Here, as long as I get nervous, I know that I need to be well, some about some to 15. Next day, I'm getting more sure about the thing like
After many years, on the data you also, and then you create an entry point of
Yeah, so they are doing the pilot. So that's I mean, I think it was a rumor, right, about so Russia was doing a big account, no? And I guess that there's more than 1/3 of accounts in paper, and they are robots.
Yeah.
So, and they are using for stealing the computer from different persons, right? I mean,
the playground, I think you stand as the teacher experience of being part of the one teacher is a class and all of this. I want
what to use the data. Not because by the end, you should be aware of how much you want it. Okay, so you will sell your data at a price. I know, somebody's like, this is
this is the device connected to our people and some sort of local data set. So it's our other devices.
definitely it's a local model. Okay, so train your local model, and then you'll show that you want to train your model, your local model, and then what you say is your local.
Okay, so if I come in, Martin has one of those devices in the phone. And I can read it, like Martin comes as the device recognizes Martin. And Martin speaks to that device.
You are training with your data, you are training with your friends' data, probably it's model, even if there are very steps in the names, but we also we have to identify the names for starting them. And this is the point, right? We can ask the interaction. But the point is that the interaction that Martin had before improved not interaction, but this is essential.
business, so we are present. Okay, I think